Assalamualaikum and very good morning to all of you. So for the lab experiment 4, the topic is series RL and RC circuit. So for the first activity, we need to simulate the circuit based on figure 4.6 in the lab sheet. So for the activity 1, we need one AC power, one ground, and then we need three resistor, which is we need to put it in parallel, and then we need one inductor. So next we need 4 multimeter and 1 wattmeter, which is the 4 multimeter we need to change 1 ammeter, and then the 3 others we need to change it to voltmeter. Then followed by the lab sheet, we need to change these 3 resistor to 33 ohm. And then for inductor, we need to put 50 mH. After that, we need to connect the circuit. After done connect the circuit, we need to set up the AC power to 10 volt 50 Hz based on the lab sheet. Based on the lab sheet, we have to run the simulation to measure the I, VR, VL and power. Then we just need to charge the AC supply. We need to change the AC supply, follow the lab sheet from 10 volt until 100 volt. So for table 4.2, we just need to change value resistor from 100 to from 33 ohm to 100 ohms, and just run the simulation.
Assalamualaikum, my name is Muhammad Shakir. Today I will present about activity 2. Firstly, we have to choose AC power, and then we go to choose a multimeter, and then ammeter, multimeter, and the third one also multimeter. So we just connect all the component. Make sure connect carefully. Sorry, this is not wattmeter. So we choose wattmeter, and then we have to connect it carefully and correctly. Just choose the resistor 100 ohm resistor, and then for capacitor we choose to 28 microfarad, and then we connect with the resistor with the wattmeter. The resistor go to capacitor, and then connect all of them, and then connect ammeter with the circuit. So we connect it, and then we change firstly for 10 volt and 50 hertz for frequency, and then for first multimeter we choose ammeter. For the third and fourth we choose voltmeter, and then we have to make sure we put the ground, then just run. So this is result for the 10 volts. And then we choose 20 volt, and this result for the 20 volt, and then 30. This is the value for 30, and then for 40, this is for 40, and then for the 50, this is the result for the 50 volt, And then for the 60 voltage, and then 70, this is result, this is the value for 70. And for 80, for 90 volt. And then for the last one, we choose 100 volt, and this is the value. So that's all for the first circuit, and then we go to the second circuit. So firstly, like usual, we choose AC voltage, and then we choose multimeter, first multimeter for ammeter, and then we choose voltmeter. This circuit just using third multimeter, one for ammeter and two for voltmeter, and then we just connect all of the component. Also make sure they are connected correctly, and then we choose for resistor, we just use 50 ohms parallel to the voltmeter. Then we connect. So we have to connect it correctly. We just adjust the wire. So after that, we have to, for the circuit we choose, we have to use 3 capacitor. First for 4 microfarad, the second one is for 8 microfarad, and the third one is 16 microfarad. This is circuit for parallel for not enough space, we have to adjust. A lot of the capacitor is parallel. So connect to the AC power. Negative over there. And we also have to put ground like usual. And then for first emitter, sinusoidal, and multimeter, first we choose voltmeter. For frequency 50, voltage 10. So sorry, this is not C, this is the correct for VRMS. Wait. Ten and 50 hertz, and then we run. So this is for the 10 volt for the circuit. For 20, we have to run for 10 until 100. Then this is for 30 volt. This is 40, the value. This is for 50 volt. This is the result. 60 volt, this is value for the 60 volt. And this is for the 70, and 80 volt. And then for 90, and then for the last one we choose 100. This is the value.
Okay, for activity 3, based on the result in table 4.1 and 4.2, plot a graph of VR versus I, VL versus I, and P versus VI. As you can see, for table 4.1, VR versus I and VL versus I graph is linear graph, while P versus VI, the graph a little bit curved. For table 4.2, VR versus I and VL versus I, the graph are same, which is linear graph. Meanwhile, for P versus VI, the graph is curved. So for the question B, draw to the scale of phasor diagram for the circuit based on the voltage reading obtained when I equal to 1 ampere. To draw the scale phasor diagram, what we need is we have to find XL, uh, load impedance, voltage, theta, VR, and VL, and we can plot the graph over here. Same goes to 4.3. We have to find XL, Z, and V, also theta, to plot the phasor diagram. Next, for question 2, based on the result in table 4.3 and 4.4, we need to plot a graph of VR versus I, VC versus I, and P versus VI curve. As we know that for table 4.2 and 4.3, we use capacitor. So the graph for VR versus I and VC versus I is linear graph. Meanwhile, for P versus VI, the graph is a curve. Next, for table 4.4, the graph are similar to the table 4.3, which is VR versus I and VC versus I is linear graph. And the graph for P versus I, the graph a little bit of curve because for first reading the VI is higher than second reading. Next is draw to the scale the phasor diagram for circuit based on voltage reading obtained when I equal to 1 ampere. So for table 4.3, to find the scale of phasor diagram, we need to find the Z, theta, and XL. Same goes to the 4.4. That's all for me. Thank you.